So, what we are going to take a look at here is dividing polynomials to see if we have a factor, or if we can break it down into a factor plus a remainder. So, polynomial long division is pretty similar to numerical long division. What we want to do is, if we have a division problem like this, I'm going to set this up so it looks like a long division problem. Okay, I want to divide x squared plus 7x plus 12 by x plus 3. The process to do this is to look at just the first term over here and just the first term over here. I want to see what I have to multiply this by to get this. Well, I would have to multiply x by x to get x squared, right? Whatever I have to multiply this by goes up here. Now I'm going to take this and multiply by everything. So x times x gets me x squared, x times 3 gets me 3x. I am then going to subtract that whole thing. 3x gets me 4x. Now, just like long division, I bring my next term down. So this becomes 4x plus 12. Now I repeat the process. I want to see what I have to multiply the first term by here to get this first term. Okay, well, I would have to multiply x by 4 to get 4x. Right? So 4 is going to go up here. Now I multiply 4 times x and 4 times 3. So 4 times x is 4x. 4 times 3 is 12. And we subtract. Here, both of these cancel out. And we just get nothing left over. So what we have determined here is that I can rewrite x squared plus 7x plus 12 as x plus 3 times x plus 4. Okay, that's what this statement was saying up here, right? So we're saying that x plus 3 is a factor of x squared plus 7x plus 12 because I can rewrite x squared plus 7x plus 12 as x plus 3 times x plus 4. What's your question, Riley?
Well, no.
For this problem, it absolutely would make more sense to just factor it. This was just a simple introductory example. We're going to look at more complicated ones that.
You can't
Right. Yeah. All right. So let's try another one here. Okay, let's take a look at B. So my setup, I want to make it look like a long division problem. I'm just looking at my first terms. So what do I need to multiply x by to get 2x squared? 2x. So now I take that 2x and multiply it by both of these. So 2x times x is 2x squared. 2x times negative 3 would be negative 6x. And now I put parentheses around and subtract. So 2x squared minus 2x squared, those cancel. And now I've got x minus negative 6x. So that would be 7x, right? If I'm subtracting a negative, that's really adding. And then I bring down my next term. So plus 6. Repeat the process. So just looking at the first terms, what do I have to multiply x by to get 7, or to get 7x. 7. So put my plus 7 up here, and then multiply 7 times both of these. So 7 times x is 7x. 7 times negative 3 is negative 21. And subtract. So 7x minus 7x cancels. And now I've got 6 minus negative 21. 27, right? That means we're adding. Well, so now, this one didn't work out as nicely as the last one, right? The last one we had 0 at the end. This time we did not end up with 0. We got a remainder. So, in this case, x minus 3 is not a nice factor of 2x squared plus x plus 6. What this means, okay, if I get a remainder, we're going to write it like this. Okay, we're not gonna, whenever we don't write this down, okay, but if you remember back to like 3rd or 4th grade when you did long division, you wrote remainder of 27 like that. For polynomials, the way that we're going to write remainders is put 7 over x minus 3. Okay? That's the way that we're going to write a remainder if we get a remainder. Okay? Technically, we could have done that up here, right? We could have said plus 0 over x plus 3. But 0 over x plus 3 is just 0, right? So what we actually determined here is that I can rewrite 2x squared plus x plus 6 as x minus 3 times 2x plus 7 plus 27 over x minus 3.
Do we write it out like that every time?
No. If the problem just says divide using long division, then just this would be our answer. I'm just trying to show you like what we actually did. Right? Dividing tells me that I can rewrite this as this times this. You okay with that one? Yeah, it's still over here. All right. You guys think you can try C? Go ahead and try C here. Okay. Yeah.
Can this be our homework?
Exact problems we're doing right now. Problems like this.
D and E.
No.
Sure.
There is no execute.
What if I ask nicely?
Yeah. I remember this distinctly. No execute. I swear you do. Am I right? There's no execute, so you have to put something there. You can't just like leave it blank.
Is that minus 2? Then negative 4 is plus 9.
Yeah.
Minus.
I don't know what you're right. No, because you can't have a free answer between them. There's an X-rays to the form, there's an X-rays to the bird, and then X-rays.
15
Alright.
Minus 0x to the third, or is it plus x? It doesn't matter. Okay. So.
Wait, should I subtract or add 0?
Doesn't matter.
Alright, for C, did we get something like this?
Yes.
The one, yeah, that was though, actually.
So it looks like some of you have jumped over to the back and are taking a look at D and E. Okay, so on these ones we've got a little bit more going on. Okay, so I want to do D together here. On this one, we've got a 4-term polynomial divided by a trinomial. Okay, so I'm going to set this up in a very similar way. Right? I'm going to have x squared minus x minus 6 outside of my division symbol. Then on the inside, I'm going to have this polynomial. This one is slightly different than ones that we've worked with down front because we're missing a term. We don't have an x cubed. We have to account for that. Okay, we have to go in chronological order here. So if I'm missing an x cubed, I need to put a 0x cubed in here. Okay, we have to make sure that if we're starting with a 4th degree, I'm accounting for every degree less than that. So I'm going to write this as x to the 4th plus 0x cubed minus 13x squared plus x plus 35. Okay. Now we're just going to go through the same process. I'm just looking at the first terms, saying, well, to get from x squared to x to the 4th, I would need to multiply by x squared. So now I take this and multiply all 3 of these by x squared. So times x squared would be x to the 4th. X squared times negative x would be negative x cubed. X squared times negative 6 would be negative 6x squared. And we subtract that whole thing. So these cancel out. 0x cubed minus a negative x cubed would just be positive 1x cubed. Negative 13x squared minus a negative 6x squared would be negative 13 plus 6. So that'd be negative 7x squared. And then bring my next term down. And then repeat the process. So to get from x squared to x cubed, I would need to multiply by x. So then x times x squared is x cubed. X times negative x would be negative x squared. And x times negative 6, negative 6x. And subtract. X cubes cancel. Negative 7 minus a negative 1 plus 1. So that'd be negative 6x squared. 1x plus 6x would be 7x. Bring down 35. And do it one last time. So x squared times negative 6 would get me negative 6x squared. So minus 6. Now, negative 6 times everything over here. Negative 6 times negative x would be plus 6x. And negative 6 times negative 6 would be plus 36. So subtract all of that. These cancel. 7x minus 6x would be 1x. 35 minus 36, negative 1. You all right? Okay, so we can't go any further. That's my remainder. Okay, my remainder is x minus 1. So we take that remainder, put it over what we divided by. So plus x minus 1 over x squared minus x minus 6. Okay, so again, what we just determined is that we can rewrite x to the fourth minus 13x squared plus x plus 35 as x squared minus x minus 6 times x squared plus x minus 6 plus x plus 1 over x squared minus x minus 6. Questions? All right, you guys try the last one. Yeah, I'll leave that up there.
Is it always going to be plus the remainder?
Yeah. I would never. I'm not allowed. So I also this
I'm glad there's so much room on there. Did you get X plus
Okay. Well, you're wrong.
Don't listen to him, Mr. Sash.
So,
Sash bullying.
Both from dudes. So yeah. Dude, I did.
X.
Nice. See, I've got a remainder of 8.
Nice.
Did we get something like this?
Yeah.
Which means
Did we get this? Okay, so big part of the setup here was rearranging our terms to start with the highest power and go down. And we were actually missing 2 terms here, right? We didn't have an x to the 4th or an x, so we had to put in a placeholder. We had to put in a 0x to the 4th and a 0x. Right? Then we just go through the process of figuring out what we need to multiply the first term by to get the first term here. Continue that all the way down until we can't do it anymore. Any questions on polynomial long division?